All right, in lesson 9.4, we are going to solve quadratic equations using the quadratic formula. So, when we're talking about solving the quadratic equation, we're talking about finding the value of x. So we've just got done summarizing in our last, 2 lessons ago about all the different ways, right? We're talking about the roots, the x-intercepts, the zeros of the equation. So, we know that we have lots of different ways in which we can do this, by graphing, by factoring, and so forth. Well, sometimes we have a non-factorable trinomial, or, it just is going to maybe not be a simplified radical or something like that, or it might be irrational. So therefore, we want to use this formula and plug in the values of a, b, and c. A, B, and C are the coefficients of each of the 3 terms, okay? So here is the quadratic formula. It's x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. A is not equal to 0, and b squared minus 4ac is greater than 0. And this is called the quadratic formula. And I'm going to play a cute little song for you in just a bit. We have several songs. You can find them anywhere on the internet, but I found one that I thought kind of sing-songy here.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Boy, that was something. All right, so let's take a look at using this. The main thing you're going to want to do is identify your A, your B, and your C, okay? So A is equal to 2. Here it shows you right here. Right here, it kind of shows you're substituting in 2 for A, negative 5 for B, and 3 for C. So we're just going to use substitution and then simplify. So 5 plus or minus the square root of 1, so that can give us 5 plus 1 divided by 4, or 5 minus 1 divided by 4. And we have 2 solutions then, 3 over 2 or 1. So we'll see about that in just a minute. Let's erase this. All right, number 1. So in this, it's already set up. I want to identify A is equal to 1, B is equal to negative 10, and C is equal to 16. Okay, so we have our x is equal to our negative b plus or minus the square root of b squared minus 4ac all over 2a. And feel free to, my C almost looks like a exponent there. I don't know why. That's crazy. All right, there we go. Then we just substitute in. So we'll have negative b. So we have the opposite of negative 10, right? Plus or minus, we'll have the square root of negative 10 squared minus 4 times 1 times 16 all over 2 times 1. So I'm going to kind of continue on down here. Sorry, number 4, you're getting the boot. Right. So we'll have a positive 10 plus or minus the square root of negative 10 squared is 100. 4 times 1 times 16 is going to be equal to minus 64. And then all of that is over 2. So let's simplify. We'll have 10 plus or minus the square root of 36 all divided by 2. So this is going to equal 10 plus 6 divided by 2, and it's going to equal 10 minus. Why is it this? I don't know. 10 minus 6 all divided by 2. So we'll have 16 divided by 2 here would be equal to 8, and we'll have 4 divided by 2 equals 2. So our solutions, we get x is equal to 8 and x is equal to 2. Okay. Why don't you pause the video and try number 2? Pause the video and try number 2. I know it's a lot. We'll skip number 5 here for you. We'll skip number 6 here for you too. Go ahead and pause the video. All right, when you solve this one, all right, you got down here and you probably got x is equal to, what'd you get? 2. And x is equal to negative 4. If you did not, you may want to recheck your steps. So 2 and negative 4. And then I'll go ahead and work on this one. So a is equal to 3, b is equal to negative 1, and c is equal to negative 2. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So we'll have, I'm just going to deal with that negative now. So we want the opposite of a negative 1, so we'll have 1 plus or minus. We're going to have negative 1 squared, which will be 1, and then minus, and then 4 times 3 is 12. 12 times negative 2 is a negative 24. And then put that all over 2 times 3, which is 6. Okay, so x is equal to 1 plus or minus. Well, when you take the opposite of negative 24, you're going to have 1 plus 24, so you'll have 25 and 6. So we get x is equal to 1 plus 5 divided by 6, and we get x is equal to 1 minus 5 divided by 6. So 6 divided by 6 is equal to 1, and negative 4 divided by 6 is equal to a negative 2/3. So here are our two values of x for number 3. That was number 3. Okay, so now we're going to look at the discriminant. So it says the expression that's under the radical right here. You can see the discriminant, b squared minus 4ac. It's the discriminant because it pretty much has all the power. It's going to tell us whether or not we're going to have any real or imaginary solutions. Because it's under the radical, we can use this value to determine the number of real solutions that we'll have, which is also the number of x-intercepts that the graph will have. So when we have greater than 0, right, we're going to have 2 real solutions. Let's see this. Look at this here. We'll have 2 real solutions, 2 x-intercepts, okay? When it is equal to 0, that means that pretty much the vertex is falling on the x-axis. You'll have 1 real solution and 1 x-intercept. When it is less than 0, okay, this is when you have this negative value under the radical. We do not have real solutions. We don't have any real value to understand, like what number times itself will give you a negative value. We don't have one. So there's no real solutions, no x-intercepts, and that's when the parabola will be kind of floating above the x, or if it's going down, it could be floating below. Anyway, so yeah, if we have the discriminant as a negative number at this point, in high school you will be dealing with that and being able to simplify it using the imaginary numbers. So for now, let's determine the number of real solutions. So we're going to use the discriminant right here, b squared minus 4ac. Okay, so if you have a 76, we know that it's greater than 0. You have 2 real solutions, 2 x-intercepts. When you get 0, you're going to have 1 real solution, 1 x-intercept. So determine this. So we want to use the discriminant, b squared minus 4ac. So we'll have 6 squared minus 4 times negative 1 times 3. So 36, and then we'll have 4 times 3, so we'll have plus 12. And 36 plus 12 is going to give us 48. 48 is greater than 0, so we'll have 2 real solutions. Okay, that also gives us 2 x-intercepts. Here, again, b squared minus 4ac. So when you substitute in, again, you'll get 6 squared minus 4 times 1 times 9. So 36 minus 36, we get 0. This is going to give us 1 real solution. This also gives us 1 x-intercept. So go ahead and do number 10. When you simplified it, you should have gotten down to a negative 26, and in this case, we have no real solutions, no x-intercepts, okay? This would be imaginary.
Okay, time for some real-life application. So this problem is telling us, it says the number of northern Rocky Mountain wolf breeding pairs, X years since 1995, can be modeled by this equation. A lot of decimals here. Okay, when were there about 55 breeding pairs? So basically, that's the output value Y. So we want to find X values when Y is equal to 55. So we have 55 is equal to the 0.34 x squared plus 3. So we're going to go ahead and subtract 55 from both sides. And we'll get 0 is equal to 34 hundredths x squared plus 3x. And then we're going to get minus 46. We're going to go ahead and use the quadratic formula to find x. Okay, it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug in our values from a, b, and c. Okay, so, and I'm going to go ahead and drop this decimal right here. So if we have negative b, we have negative 3 plus or minus the square root of, and then we'll have 3 squared minus 4 times this 34 hundredths times negative 46. All of that is going to be over 2 times the 34 hundredths. Okay, let's simplify underneath this part, this 4ac, so we get x equal negative 3 plus or minus. We'll have 9, and this becomes positive, and I have 62 and 56 hundredths. All that is going to be over 68 hundredths. Okay, let's add these together. So negative 3 plus or minus the square root of 71 and 56 hundredths all over 68 hundredths. Okay, so we have two possibilities here. We have x is equal to negative 3 plus this square root of 71 and 56 hundredths over 68 hundredths. And that makes x approximately equal to 8. Okay. Or we have, and we want to write the next one down, or we have x is equal to negative 3 minus this 70 square root of 71 and 56 hundredths over 68 hundredths. And that gives us x is approximately negative 17. Now, x is a measurement in years, and it has to be a positive value. So this negative 17 is really erroneous to us. So we really only need this value. So we're talking 8 years after 1995. And if we calculate that, that's 1995 plus 8, there were 55 breeding pairs in the year. So there, let's see, there were 55 breeding pairs in the year 2003, because 2003 is 8 years after 1995. Okay, so a lot of number crunching that went on there. Make sure that you can get that to work out on your calculator, and then also make sure that you understand the idea of an erroneous solution that we would throw out, because a negative quantity for years does not make sense. Okay? And your vocabulary and concept check. Please select one, write in complete sentences. And if you have any questions, be sure to let me know. I look forward to seeing you in class tomorrow, and have a great night.